Good morning, good afternoon, or good evening, depending on where you are in the world. And thank you for joining this learning experience brought to you by Ngrok. My name is Cody, and welcome back to Techstrong Learning. Before we dive into things, I have just a couple of notes to review with everyone. First of all, we are recording this session today. So if you miss any of our conversation, if you'd like to watch again at a later time, or if you'd like to share this with the rest of your team, we will be emailing you a link to access the on-demand recording shortly after we conclude this live session today. Now, if you'd like to get involved, there are a couple of ways to do so. Your first option is to use the chat tab on the right side of your screen. And when you find that chat tab, I'd like you to let us know from where in the world you're joining from today. Now, for specific questions, we want you to submit those to the Q&A box on the right side of that chat section. And we're going to do our best to answer as many of your questions toward the end of our program today. So be sure to send them in when you have them, and we'll do our best to answer it live on air today. Additionally, if you jump to that handout section, you'll see there are some resources, including a copy of our slides there for you. So feel free to download all of that while you're here with us today. And of course, we will be selecting 2 of our most engaged attendees to win a $50 Amazon gift card. So ways to be eligible for this giveaway are to send in your chats and questions, but you can also fill out our survey, which will be touched on at the end of the program, but it is in the handouts for you. So moving straight into our topic, we're going to be discussing modern Kubernetes Ingress with Ngrok. I'm joined today by Chad Tyndall, Field CTO and VP of Worldwide Solution Architecture at Ngrok. And we're also joined today by Salil Subhakrishna, Product Manager of Developer Growth at Ngrok. So Chad and Salil, thank you both so much for joining us today on Techstrong Learning. Chad, do you want to dive us right into things?
Absolutely. Let's get started. Again, just quick introductions. I'm Chad Tyndall, the Field CTO here at Ngrok, and I'm joined by my colleague Salil Subhakrishna, one of our senior PMs. Among other things, Salil's team owns the Kubernetes Ingress Controller and the Gateway API implementation, which is what we're really here to dive into today. So why don't we get started? First, we're going to have a little bit of introduction about Ngrok. We'll talk about the Kubernetes specifications and how we fit into that picture. And then we'll have a really deep demo that Salil is going to give us at the end, showing us how all this stuff fits together. So just a quick introduction about Ngrok. So Ngrok is here. It solves problems in software networking infrastructure, specifically application delivery for your engineering and IT organizations. So just to help give you some perspective on where Ngrok fits in your technology stack, we could take a look at some common categories of software you're likely familiar with here: load balancers, firewalls, API gateways. Hopefully all of these terms, you already know what they mean, and you probably use them in your day-to-day application deployments. Global server load balancing, of course, ingress controllers in the Kubernetes world, identity-aware proxies. There's others, web application firewalls, things like that. So if you ask Gartner, and if you ask your IT teams, they probably think all of these are separate categories, different cost centers. Each one of these is likely fulfilled in your stack by a different best of breed vendor, right? You might have a different vendor for your load balancer, your firewall, your API gateway, and all of that. And, but your developers, they don't really think of all of these things as separate categories from their perspective. From their perspective, this is all just lumped into a single category, something we call application ingress. This is all of the different components in your stack that network traffic has to flow through before it actually gets into the developer's application or API. So here at Ngrok, we've built a solution for modern software development that unifies all of these different categories into a single cloud service that is programmatically configurable and always on. Now, there is a technical fragmentation problem here because each additional piece, each one of these components adds cost. It adds operational overhead. It complicates the observability story inside of your organization. Not all application services use all these behaviors. I mean, they are all best practices, but because they're so hard to set up, sometimes applications will use only some of them, and we might only use all of them for the most critical applications. All right, there's an organizational problem as well because Ingress has many different stakeholders. You have application engineers, you have platform engineering, you have network operations, you have network security, you have application security, and each one of these tends to be different teams inside of large companies. And each team might own 1 or 2 or 3 of these components and actually be responsible for it. So when you want to get application delivered into production, you usually open a ticket and you have to coordinate and all of these different teams to make sure everything is set up in a way that actually works for the application and has everything that everybody needs. Right. So there's a lot of technology complexity. There's a lot of organizational complexity involved in orchestrating all of these different components. And this complexity gets even worse when you go into a hybrid or a multi-cloud architecture, because not only do you have to contend with the on-premise solutions you might have, like you might have an F5 load balancer, or you might have an Imperva WAF, you might have a legacy API gateway that you're using on-premise, and all of that. But now your DevOps teams might want to use each cloud provider's native implementation for each one of those categories. So Amazon has their own WAF service. Amazon has their own load balancer service. Azure has their own WAF and API gateway. Google has their own load balancers and API gateways, for example. And of course, each one has their own separate Kubernetes service that they have. So, this complexity gets multiplied, right? And just blows out kind of an explosion of complexity, making it even harder for your applications to move through the various parts of dev, QA, staging, production, all those different life cycles. So as we know, the more complex something is, the more expensive it is, the longer it takes to get it right, the more opportunities there are to make mistakes that could lead to outages or security vulnerabilities, kind of all of that. So that's where Ngrok comes in, because we take all of those distinct components and we collapse them down into a unified stack. And we run that stack at our network edge in all of our points of presence around the world. So your developers could use it in development on their laptops while they're prototyping new features. Maybe they want to share those features with other developers in their team. Maybe they want to share those features with third-party partners who might need early access, that kind of thing. Once you get into the QA part of your life cycle, it can be integrated into CI/CD pipelines during that part of the process. And then when everything's ready to launch, you can use Ngrok as your Ingress platform for your staging environments, for your production environments. And this gives you a significant cost advantage in terms of automation, configuration, security, observability, because it's going to be the same across all the different parts of the development lifecycle, right? Whether you're running on-premise, whether you're running in a cloud provider, whether you're running in a hybrid on-prem cloud or a multi-cloud architecture. So making things simpler, it not only makes them cheaper, but it allows you to deliver your applications faster and deliver value to your customers faster. So Leo, I don't know, I'm just checking in here. Anything you want to add, or should we keep going? Nope. All right. Okay, so what are we on? Slide 6. So let's go to slide 7. There's a lot of functionality in here. We're going to look at some of this later: traffic insights, observability. So Leo's going to demo some of that in his demo, but just wanted to throw that up there. So why are we here today? So excuse me. When you do get to the point where you're going to launch into staging and production, oftentimes that will mean deploying everything into a Kubernetes environment, right? You don't have to, but that is kind of fairly common in this world. So Ngrok works whether you're using Kubernetes or not. Today, we're going to talk about the Kubernetes side of things. It's important to understand when you get into the Kubernetes world that there are two different specifications inside of Kubernetes for how to define your application networking. The original method that people have been using for years now is something called Ingress controllers. And the new we'll call it the new sweet hotness, is something that they've called the Gateway API. Now that's confusing because it sounds a lot like an API gateway, but the Gateway API specification in Kubernetes doesn't have anything to do with API gateways. It's just an unfortunate use of the same words to mean something different. The Gateway API is just the name of the new Kubernetes standard API for defining application network components via something called gateway and route objects, and implementations of this API like the Ngrok Kubernetes operator, which provide the actual code implementing those objects. So Leo, do you want to talk us through maybe some of the differences between the old way and the new way?
Yeah, so I think it probably helps to start with where Kubernetes Ingress was the original implementation, the original solution, and it involved creating Ingress objects so that you could basically connect. You basically have a north-south traffic solution for getting traffic into your cluster, and then figuring out where it actually needed to go to the services it needed to go to. But because of the way it was built, there were a lot of limitations and challenges. A couple of them are listed here.
But one of the challenges was around RBAC. In order to set up Kubernetes Ingress, you had to have substantial access to all different pieces of the cluster. And as the emergence of platform teams became a thing where certain people have access and management of the cluster, they're so-called cluster operators who are managing and dealing with clusters as a whole, as opposed to the application developers who were building services and needed to actually deploy those applications. It became kind of a challenge from an RBAC perspective. Another big challenge that came up was just Kubernetes Ingress was very simple. So if you wanted to add more customizations or things that were specific to whatever implementation existed, annotations were the only solution. And you would have to build other objects and you have to create annotations. And you'll see some of that in my demo later. But that was much harder to work with and created added complexity. And Gateway API is the network SIG's attempt to basically take all these kinds of problems and solve them by building something that's designed for different groups and different teams to support both cluster operators and application developers. It's designed to be more expressive so you can embed more of those things that you want to do within the objects themselves, and is designed to solve a lot of the individual problems that have come up out of Kubernetes Ingress. Ingress still works and it's very simple, and it does the job if that's what you're looking for, but the Gateway API adds these extra capabilities at the cost of additional complexity and overhead to manage these objects.
So was it the case that essentially application developers would have to be given sort of root access on the cluster in order to deploy their Ingress objects? Was that the problem?
Either that or the cluster operators would have to take on additional overhead to set up and manage everything on their behalf.
I see. Okay. Yeah.
So neither option is particularly good, but with Gateway API, they've sort of split that out. So different roles have different levels of permissions and set up different things.
Yeah. And so also the Ingress controller was really focused around HTTP and HTTPS routes, and doing anything at a lower level like UDP or TCP or TLS kind of required custom extensions, annotations. Those annotations would look different if it was using Ngrok's Ingress controller versus the Nginx Ingress controller or the Traefik Ingress controller.
Yeah.
Right?
Well, one of the big goals and benefits of the Gateway API is that if you're looking at different implementations of the Gateway API from different vendors, there is a lot of overlap in terms of how they look. So routes and gateways will look similar in some ways when you look at these different implementations. If you're looking at Kubernetes Ingress, it's kind of a wild west. All of them look totally different, and even it's a less consistent standard.
It was a bit of like embrace and extend for each implementation, made it totally different for the configuration side of things, right?
Yeah, I mean, there's other than the fact that they have Ingress in them, like typically the Ingress Kubernetes Ingress implementations all look just wildly different. But Gateway API, if you look at some of the different ones, there's at least a degree of consistency, and they look similar. And it's kind of, if you see one, you can learn how to adapt to another.
Is there any sense of just in terms of the specification and what the Kubernetes guys are doing at large, are they talking about deprecating the Ingress, or do you think that both of these will sort of be options moving forward relatively indefinitely?
I think in the short term, they're both going to be options. I suspect in the future, Kubernetes Ingress is going to maybe not fully disappear, but become less popular. I don't think that the network SIG is doing much, if any, development on Kubernetes Ingress outside of sort of bug fix and keep the lights on stuff. I don't think they're trying to add net new features. I think the sort of impression that I get is that there's a belief that Gateway API is kind of the new way to do it, and it's still being actively developed. So, for example, we talked a little bit about supporting things like TCP and TLS and UDP and gRPC. All of the routes for those different protocols are still experimental; they're not stable yet. So, until they get to that point, there's not going to be sort of a wholesale switch over, both within the network SIG and I think even just in the community at large. Until we get to that point where the majority of the components in the Gateway API are considered stable. But I think there's enough that's been built that they're starting to push people to transition over. And if you look, there's like a few dozen different implementations of the Gateway API that the network SIG themselves are aware of, because you have to actually tell them that you have an implementation. So there's definitely a lot of interest from a lot of the major players in the networking space, the public cloud space, all of that.
All right. So let's look at some architecture just so people can kind of understand how this all fits together. If you're using the Ngrok Kubernetes Ingress Controller, essentially you'll deploy our operator into your Kubernetes cluster. The Ngrok agent will be running, or the Ngrok Ingress Controller software will be running inside of the Kubernetes Ingress Controller. It will use our API to configure edges inside of our points of presence. Salil's going to show that in the demo. So you see the Ngrok picture out there on the internet. We would take your URL, whatever the URL for your application is going to be, myapp.ngrok.app, or and I think today it's going to be salil.ngrok.app or something like that. That DNS entry would route to Ngrok's points of presence globally around the world. Clients hitting that would be routed to whichever Ngrok point of presence is closest to them, right? Because we run in different regions all over the world. And we would accept that ingress. We would run it through all of our different security policies, all that stuff that we talked about earlier. And once it makes it through all of our security policies, then we would send that traffic into your Ingress controller, and the Ingress controller would then route it to the appropriate service and pod behind the scenes. Is that right? Yep. Salil, is that right?
That's right. Yeah. Sorry, coming up. Yeah, that's right. Basically, the Ingress controller is kind of our bridge from the Ngrok service all the way out to the end services. And you'll see in the example kind of what that looks like.
Right. So, and then in the new picture, as you said, the standards body has gone and defined these different personas. Infrastructure providers, that's people like us, right? Okay, so that's the vendors who are actually supplying these products. Then there's the cluster operators and the application developers. So, like, what kinds of, I guess, permissions should each one of these have? How do we think about these?
Yeah, so the infrastructure providers are not really going to be doing too much to actually put anything in your cluster. They're really going to be, like you said, people like Ngrok or sometimes the public cloud providers building the actual implementations. And then, as you'll see in kind of my example, the gateway class that they're setting up is sort of it's basically kind of the way of translating all the other things into what controller should be used and what CRD should be used and so on. The cluster operators are going to be kind of your cluster super users. They're going to be the ones who have access to pretty much everything. They're managing. They're probably the ones who are spinning up the clusters, managing them. So they're going to have pretty substantial permissions. The application developers, it's going to depend on the organization. In some cases, they might have access to certain shared namespaces or resources. They might just have access to their own namespaces where their applications are being deployed. In the example I'm going to be showing earlier, I'm going to be putting everything in the same namespace, but one of the things you're going to be able to do is to have gateways set up in centralized namespaces by the cluster operators, and they'll sort of create everything. And then the application developers will be able to deploy both their applications and the routes which they will create and link those to those centralized gateways. So they'll have control of their own namespaces and they'll just sort of link it through. There is potential for having developers keep their services and their routes in different places, but that's something that Ngrok's operator doesn't support at the moment, and we don't have plans to support that in the near future.
So the architecture picture looks very similar. We still have the Ngrok cloud. We have the application endpoint sitting at all of our points of presence is going to come through. Then traffic, once it makes its way through our SaaS, it's going to make its way into the Ngrok gateway running inside of the cluster, which is managed by the cluster operator, I guess, is what we take from this picture. And then the routes themselves would actually be set up by the application developers.
Yeah, and sort of the gateway is the central point where we determine what is actually going, is it actually going into that particular place? And then the routes are saying of all the traffic that's coming in, which ones need to go to which specific services.
Right. Good. Yeah. So this is great. And I imagine it'll be like anything else where the old way and the new way coexist for several years. This is going to take people time to migrate. They got to upgrade. They probably have to change a lot of their deployment code and all of that. Right. So there's a lot of this is going to be customer driven in terms of how long the old way sticks around.
Yeah, and I think one thing that we'll probably start to see is sort of parallel deployments where people are using Kubernetes Ingress and then are shifting to Gateway API a little bit at a time. and starting to move individual services over.
And is that something you would do in the same cluster, or is that like you would have an old cluster and a new cluster?
I would imagine you probably want to have it in the same cluster because you don't want to sort of rebuild everything. You could certainly do that. That's but yeah, I mean, like the example that I'm going to show, I'm going to have an Ingress controller and Gateway API implementation both in the same cluster. They're going to be in separate namespaces. So that's probably where I would expect the sort of bifurcation a little bit, just because namespacing, it allows us to keep everything separate. So you might see some duplication in some cases of certain services running in the same place, running in the same cluster multiple times, but with different namespaces.
Got it. Yeah. Well, I think it's good to point out that these things can coexist even in the same Kubernetes cluster, and likely will, like you said. Before we dive into the demo, I just wanted to introduce a few of our core features. These are not Kubernetes specific, but Salil is going to show some of these during his demo. So it's good to know what's going on. We do have the ability to add authentication in front of any endpoint. So I don't know if he's going to do this or not, but yeah, you could very quickly, like, say, before someone can hit my site, they have to do an OAuth authentication through Gmail, and only the ngrok.com Gmail domains can use this website. For example, maybe it's an internal app that only our employees are supposed to have access to. Or if it's an API, you can do JWT validation in front of your API endpoint, so you don't have to write the code to do all the JWT validation. Of course, we support rate limiting, so that tends to be something somewhat complicated for people to implement themselves, and it's nice to be able to just click a button and turn it on right inside of our portal or inside of our dashboard. You can do request and response manipulation, which I believe he's going to do in the demo. So as the request comes in, you can actually change it. You can add headers. You can all of that. All right, and so you'll see some of that. And as the response goes back through, you can also modify the response before it gets sent back to the original client. We have this new feature. It's called the traffic policy engine. This is how you actually wire all of these different features up into your routes. So you could say this route does a URL rewrite and it needs JWT authentication. This other route needs to block certain types of requests, but allow other kinds of requests. This route has rate limiting, but that one doesn't. So we basically provide a rules engine that you can set up on a per route basis. It's very expressive and very configurable. And then lastly, we have this observability platform, which we call Traffic Inspector. If you turn it on, it's something that you can turn on or not. But if you turn it on, then it's going to start logging the various requests that flow through your edges and allow you to see what those requests look like, right? And this is super powerful when you want to see something, either you want to see something that happened, or developers, sometimes they want to see something that came through and replay it inside of development. And so they can kind of replay the same request over and over again very easily. And Salil's going to show some of that as well during his demo. So why don't we turn it over to him and let's see the demo. All right, I can see your screen.
All right.
I see the
Cool.
terminal.
Yes. So I have a Kubernetes cluster already spun up and set up. So there's a little bit of just sort of housekeeping stuff I'm going to do. So first, I'm going to be, as I mentioned, namespaces are kind of a big piece here. I'm just going to set up a couple namespaces that I've predefined. So basically created a few namespaces that we're going to be using in this demo. The other thing I'm going to be doing is I'm going to be deploying a handful of services. Now, there's certainly ways you can do one service and have cross namespace, but just to keep it simple, I'm going to basically be deploying, it's an Echo app, so it'll receive the HTTP request and then just send it right back. And I'm creating here a service and a deployment, and I'm just sort of duplicating it across a couple of those namespaces. So let's kick that, let's get that applied. And services are created. So the next big piece that I'm going to be doing is the actual setup and installation of the Ngrok Kubernetes operator. And this operator contains both our Ingress controller using Kubernetes Ingress, as well as our Gateway API implementation. And I'm going to set them both up at the same time. So to simplify some of this, I just put the sort of different pieces into a single script that I'm going to run, but I want to run through what those commands are. So the first is going to be using Helm and just adding the repo for the operator. Now, you may notice it says Kubernetes Ingress Controller. Our original repo only had the Ingress controller, but it now supports both the Ingress controller and the Gateway API implementation. We just haven't finished going through all the renaming of stuff right yet so far, but that's what it's going to look like. When I run this, it's going to say it's already done because I installed this quite some time back, but you'll see something a little bit different if you're doing it for the first time. The next step is going to be doing an apply of this particular release from the Gateway API. This is going to be all the CRDs required for the Gateway API, the gateways, the different types of routes, and so on. If you're just going to be using the Ingress controller, you don't need to do this step. But since I'm going to be showing the Gateway API as well, I need to make sure this gets installed. And the final one, and this is kind of the big magic step, is a Helm install of the Kubernetes, the Ngrok Kubernetes operator. And so I'm just sort of doing a pretty normal install, but there's 3 important flags that I need to set. The first 2 are providing credentials. So the first one is the Ngrok API key. Because we're going to be setting up edges and potentially domains and other things, I need to have that API key provided so we can set those up. The second piece is the Ngrok auth token. And that's what's actually going to tell the agents that are running on the Kubernetes cluster who I am and that I should be connected, basically who I am, so that they know what to associate with and know that I have the right credentials and everything like that. And then this final piece is the use experimental gateway API. This is another one of those things where if you're just using the Ingress controller, you can set this to false, you can completely omit it. This flag just sets up the extra CRDs and components that are required for the Gateway API. And right now, because the Gateway API is sort of a newer thing, we are expecting the people who are using it to be more sort of experimenting and trying it out. We're making this we're marking this as an experimental thing. But what I expect in the future is we're going to have the option for people to either install just the Ingress controller, just the Gateway API, or both in the case that they want. And this is going to install it cluster-wide. So now that we've run through that, I am just going to run this script. And you can see it already exists, installing the CRDs. And this is the output once the operator has been set up. So at this point, the operator is fully set up and ready to go on our cluster. So now we need to actually start deploying stuff. So I'm going to start with the Ingress controller and run through that example first. So I have a manifest here for setting up an Ingress object. As you can see, it's just an Ingress object. I'm putting it in the Ingress controller namespace. It's going to be mapping to salil-kic.ngrok.app. And basically anything that goes there is going to this echo service. So let's apply that. And run that. And so that Ingress object has been created. And now if we go here, we can see this edges page previously was empty. But if I refresh it, I should see an edge right here. And so if I go into here.
That was created by the Ingress controller.
That was created by the Ingress controller. In fact, what I'll do is I will copy this and I'll throw it into the public chat. So if you want to go and check this out, you should be able to see it yourself. But if y'all click that link, you will see exactly what you're seeing on my screen. And so it's just taking the, basically all of the requests that went in and just sort of spitting it back. And so, yeah, that's basically kind of very simple, quick and dirty how you can spin that up. Now, as Chad mentioned earlier, we have, we have all these different sort of modules, policy engine, all of that stuff. And it's that's a big thing, a big defining feature of Ngrok. So you can add some of that in. So let's go back to my terminal, and I created another manifest here. Now, this one is creating a module, and basically what we're going to do is, in this one, is we're just going to modify the headers. So I'm going to add a header called country, and it's going to pull out the geocode that's coming in from from Ngrok. I'm going to try and delete this header if we see it. Maybe we will, maybe we won't. And then basically this Ingress object looks the same. The only real difference here is I've added an annotation here with the name of this module set. And one thing I just want to note is if you're using any of this, like making sure that the module sets and the Ingress objects are in the same namespace. That is something that it's very important to make sure that that's the case. Otherwise, it doesn't quite work the way you'd expect.
Kind of a common mistake that people make.
It's a mistake I've made. So if I can make it, I want to try and save people some trouble there. So, but we'll apply this one and
-F.
Yep. And so you can see this module set's been created, the Ingress has been modified, and then if we go back here, give it a quick refresh, and you can see there are some headers. There's a module that's been turned on, and if you go back to that same one, you'll see you should see country US. That wasn't there before. Now, one other thing I can do, and Chad alluded to this as well. I'm going to try and, right now this is sort of fully available. You all can see sort of, if you click that link that I shared in the chat, you should be able to see exactly what I was seeing. But now maybe I'm feeling like I want to keep it a little bit secret. So what I'm going to try and do is I am going to pull up a different manifest I added in, which is very similar, but throws a little OAuth in there. So we still have this original first module, but I've added in a new one where now only my email address can be secured with OAuth. And then I've added in this second policy. Now you can create policies that have module sets that have multiple modules. You can create different individual ones and compose them. That lets you sort of get a lot more flexibility. I decided to keep them separate just so I could diff the code a little easier. But let's apply this. And you can see new one created, this one's unchanged, this one's been updated. And if we run a refresh on this, you can see there's an OAuth one. Now, I should be able to open up this one because I have OAuth set up. So I can see this, but I don't know if Chad, you want to pull it up on your laptop, on your machine and confirm that you can't see it.
Yeah, I just tried it. I got an error 5511, not authorized for use by this account. Yep.
Exactly. And this is a common thing that a lot of people do, just adding OAuth in front of applications. So if you're running a service that you have on your cluster and you want people to access it, but only a couple people, you can do that. And these policies, especially OAuth, can be configured on, I did just my email. You could do
like start.ngrok.com and then I'd be able to see it.
Exactly. I can do that. I can do something like that too. I can do multiple sets of domains. I can do multiple users. You can also control lots of different scopes and all kinds of stuff there. So there's a lot of things you can do. Now, one thing I want to take before we move into the Gateway API, one thing I do also want to show is our traffic inspector, which Chad talked about a little bit earlier. So if you look at this, this is different requests that have come into that particular Salil-KSE that looked at earlier. And you can see all kinds of information about these. What we've set this particular one up to look at is we've set this one up to look at I've set this one up to do full capture, but you can also just pull some metadata. But yeah, if you look at this, you can see all kinds of information that was going in that kind of was pulled out. And there's a huge amount of data in here. And one of the things that Chad brought up is we're adding replay capability. So this is going to be extremely useful for people who are testing webhooks, because if you send the webhook once, and let's say there's something wrong on your application, you need to retest it, you can replay that webhook and it'll be an opportunity to retest and recheck that. All right. Now, I'm going to, now that we've talked a little bit about the traffic inspector, I'm going to go back to my terminal and we're going to go through the Gateway API. So we've already sort of set up and installed the components needed for the Gateway API. Now we actually need to set up and run everything. So the first piece that needs to be set up is a gateway. And so again, another manifest. The first piece is the gateway class, and that's the piece that was built by us as Ngrok, and it's really just defining it in here is to make sure that when somebody actually creates a gateway of type Ngrok, Kubernetes knows which controllers and which components to actually use. And so that's something that would just sort of be set up once by the cluster operator and kicked off. They would also create a gateway like this. So you have the gateway, again, namespacing, very important. And then within the gateway, they create a series of listeners. And essentially, these listeners are going to be checking on particular host names, particular ports and protocols. In this case, this one's going to be using HTTPS. It's going to be on port 443. It's salil-gateway.ngrok.app. It's going to be using only accepting only HTTP routes. So if somebody were to try to connect a TLS route in this case, it wouldn't accept that. And then the other thing is we're handling we're going to just sort of set all of that up as we go. And one thing to note is that because Ngrok is a SaaS product, pretty much everything is going to be flowing through our system. So this particular entry here about TLS termination, we're going to be handling the termination on our end with Ngrok. We're generating the certificates and doing all that stuff. So even though there's a definition of an Ngrok cert here, there's not an actual object that I'm creating. So once we've done this, I'm going to apply this manifest. And if we go back to our edges section, you may notice there's no salil-gateway.ngrok.app, and that is expected. The edges themselves aren't actually created when the gateway is set up. They're created when the actual routes are set up. Because right now the gateway is just a way for us to sort of send traffic, but until we know where it's actually going, we don't want to set up an edge yet. But now we're actually going to get to setting up that edge. So
the cluster operator would do the first one, and now the developer would do this one.
Exactly. And so the cluster operator will also tell the developers, like, hey, these are my listeners. Like, they might share the manifest or share information about what listeners are there and what applies, so that the application developers know how to construct their routes. And part of that is because you may notice there's a host name listed in this route, as well as one being on the gateway. And I've set them up in a way because I just set them up to be the exact same, more for simplicity than anything else. But you can also set up other sort of different, as long as there's an overlap between the host name specified within a listener and the host name specified within a given route, it'll route traffic there. So it could be something where there's a wildcard in one, or like a subdomain or something like that, and that will still kind of route things through. But essentially, yeah, this is just a route. It's an HTTP route because, again, that's kind of the only thing that's officially supported as stable by the network SIG. But it has a host name, and this is kind of going into the idea of rules. So we're having basically, if there's anything that goes to this / path prefix will go to this particular service. So we'll kick that off. And now, when we go and refresh, we see salil-gateway.ngrok.app, and I'll throw that into the chat as well if any of y'all want to check it out. But yeah, now we have, you see this looks very similar from this side, but we now have that same thing where it's available in here. And again, if we go to Traffic Inspector, you can see there's already a couple, you can see it's already accessible there. I think this one is me, actually.
That one was me. The 67 one was my IP.
Okay. Now, we talked a little bit earlier about the Gateway API being more expressive, and I want to show what that looks like. So I'm going to open up another manifest here. This is an update to the one I just showed, and you see most of it looks the same, except there's this filter section. And so there's a filter of type request header modifier, and in this case, I'm adding some more headers. Something that just marks this as being a gateway, something saying hello to me, and these two last ones should look very familiar because they're the same ones we did with that first example, except in this case, it's not adding module sets and doing annotations. It's embedded right there in inside the actual root definition. And the Gateway API has a handful of these sort of filters and other stuff built in. Request header modifier, response header modifier, redirect, rewrite, a few others. I believe there's about 7 of them. There's also something which they call the extension ref, and that's basically for organizations like Ngrok to add our own customized filters that are specific to what we're doing. And so one of the things that we're going to be doing is all of these filters right now are using the traffic policy engine that Chad brought up earlier, which is using cell expressions. So provide expressions. When they match, we conduct actions. And all of this is using that same stuff, but underneath the hood, we're using our policy engine, and we're going to be adding a generic policy filter so that if you want to add any arbitrary policy to cover the things that are not covered by the spec. So OAuth that we brought up earlier, rate limiting and circuit breaking, all that kind of stuff. It's not covered by the default Gateway API spec, but because Ngrok can support it, we're going to add capabilities to do that very soon. But now that we've done that, let's actually kick this off and apply this manifest. And you'll see nothing new is created, but there is a modification. And if we go back to this, you see now there's these policies that have been set up and created. And you can see this is kind of like what the policy document looks like, where we're adding and removing headers.
Yeah, I can see that the country gets added when I refreshed my page.
Exactly. And there's all kinds. I mean, we can do all kinds of stuff with that. There's a whole bunch of information and different things that you can do with that. And the policy engine is designed to be something that we're going to continue to grow and expand in the coming weeks and months.
What are some things that we might be adding that aren't there right now? Do you know?
In the short term, a lot of it, I think, is just getting back up to parity with kind of what we have, and being able to sort of support, because there's a lot of different pieces, a lot of different modules that we've sort of built that we don't support in the policy engine right now. So, for example, I believe compression is one that we support as a module, but we haven't gotten to that in the policy engine. That's one of the ones I know is they're working on right now. I think one of the other big things that's going to come out very quickly is just because we're dealing with this sort of, if you look at this is the sort of select, I'll put it in YAML since it's a little easier to read. But basically the way this works is there's inbound policies and outbound. So inbound is stuff that's coming in on the request, and outbound's coming on the response. We could do all kinds of, we could do a lot more kind of logic on how we handle things. So for example, we may want to say, like, if certain requests are coming from certain locations, or other things, you might be able to add or validate certain information. Or one thing that we get, like a very obvious thing that we can do, is being able to say, hey, if anyone is sending in requests, we want a particular header to be set to a particular value, and if it isn't, we just reject it immediately. That's a pretty common thing that's seen in a lot of webhooks.
Yeah.
But just being able to add that in, and being able to add all kinds of added complexity there, being able to sort of manage all of this. One of the very cool things I think you can do with this is, because it's all codified, you can manage it in your GitHub or GitLab repos. You can put it all in Git. You can track your policy's evolution over time, and just using all the sort of as code techniques that have been built for managing, not just your code, but infrastructure, all those things. You can now manage your network policies that way.
Cool. That's the whole demo, right? We've made it through?
That is it. That is it.
All right, great. So why don't we take a look and see if there's any questions here. There is one question. Can we say that Ngrok is similar to Jenkins? So Jenkins is a CI/CD platform for automating as you publish code into your GitHub. Let's say maybe you want to do an automated build, and then when the build succeeds, you automatically want to deploy it out to prod or something like that. So Jenkins will handle all of that automation for you. But it doesn't like set up the networking for you. All that stuff Salil was just showing around network policies and traffic filtering and all that stuff. It doesn't handle that, right? So you might have it run some Terraform that would set it up for you, and that Terraform would have to be different if you were going to deploy it into AWS, or it would be different Terraform if you're going to deploy it into Azure, something like that. But if you use Ngrok, then all of the configuration that Salil was just saying you can keep in GitHub would be the same regardless of whatever cloud provider you're running on, because it doesn't matter to us if you're running on Azure, GCP, or Amazon. All of the definitions inside of Ngrok are going to be the same, right?
Yeah, I would say Ngrok and Jenkins can have a number of complementary use cases. So two obvious ones that are sticking out to me are one, if you are, let's say you are, as I mentioned, you can keep policies in your code, because these are just YAML or JSON documents, and what you could do is every single time that somebody makes a change to them and pushes that change to your GitHub repository, you could use Jenkins as a CI/CD tool to basically pull the policy and then update it, and just run, connect using Ngrok's APIs to update the policy. Another use case I can think of is a lot of people, Jenkins is generally a self-managed on-premise tool. So people are running it on infrastructure they own and manage themselves. And so what you could do is, let's say that I have Jenkins that's running on, either running on a VM, or let's say it's running in a Kubernetes cluster, and I want to be able to give people access to it so they can work with it without having to SSH in or something like that. You could use Ngrok. You could use the either the Ingress Controller or the Gateway API that I showed earlier to actually make your Jenkins accessible to people outside the cluster and be able to work with it and view it, access it, use it. And using, for example, the OAuth stuff that we showed earlier, you can restrict who has access to it, and limit that accessibility to it, but still give people access.
Right. No, that makes sense. Okay, we got another question here. What's the main differentiator of Ngrok compared with Traefik or Traffic? I never know how to pronounce it. Traefik, which is another reverse proxy. It's kind of something similar to Nginx or something like that, right? Now, from the Kubernetes point of view, all of these are going to have Ingress controllers and Gateway API implementations, right? Ngrok's going to have one or both. Nginx will have both. HA proxy is going to have both. Traffic's going to have both, right? And so that's going to say once the traffic makes its way into the Ingress controller or the Gateway API implementation at the cluster, those tools will route it to the appropriate pod or service behind the scenes. However, Ngrok is unique in that we actually have a SaaS platform as well that traffic hits out at the edge around the world. So we're actually going to take that Ingress at our SaaS platform somewhere out on the internet at one of our global points of presence. We're going to process it through all of those different security policies at our edge before it even makes its way into your Kubernetes cluster. Then once it makes its way into your Kubernetes cluster, right, our operator and their operator are going to be fulfilling similar roles. But that's the main difference, is that we do a lot of processing at the edge before it makes its way to your cluster. Is that right?
Yeah, I mean, I think one of the big, I would say, value adds of Ngrok is, and I think you brought this up earlier, is we're taking a lot of the component, the way I like to think about it is if you want to take an application that is on your Kubernetes cluster and you want to make it accessible to the outside world, there's a lot of different things you have to build, set up, configure. And what Ngrok's advantage is that we take all those things, we essentially boil it down to one service that you're connecting to, and the agent, whether it's via our operator or it's our actual agent binary or via our SDKs, it's all very lightweight, and it's a lightweight thing that you're running on your cluster that connects to our SaaS platform and shifts all that stuff out there. So it's shifting a lot of that work out there. The other thing that I would say is and this is something interesting about the Gateway API itself, is one of the other things that I didn't bring up why the Gateway API sort of got started, is Kubernetes Ingress really just solved the Ingress problem, which is kind of the north-south. How do I get stuff into the cluster? Which is a big problem. But one of the other things they were looking at was more of the sort of east-west service mesh style stuff, because there's so many different service meshes out there that have been created. Istio is a common one. Kuma. There's multiple different solutions out there. And part of where I think the Gateway API is also trying to migrate to is also to build standards around those east-west service meshes. And certainly people that have Gateway API implementations will support that east-west component. I think they call it Project Gamma. But that's something that certain Gateway API implementations are looking into. We're not really looking into the service mesh side of things.
Yeah, that was another question that came up. Do we have Istio features? So that's what you were saying. Istio is a service mesh for east-west traffic between different services inside of the same Kubernetes cluster, whereas Ngrok is for north-south traffic, getting traffic from the internet into your Kubernetes cluster and back out. Right? That's the main difference there.
Yeah, we at least at this point, we haven't really looked into solving any east-west problems.
Right. Okay, another question here. Does Ngrok have the ability to reroute traffic in case of maintenance? So let's say you want to, put your service under maintenance, or, maybe you want to do A/B testing or blue-green deployments, those type of traffic policies. We do have the ability to say, some percentage of traffic, like 90% of requests at this edge go to this backend service, and 10% of requests go to this other backend service. So you can A/B test, or, gradually do a blue-green rollout, right?
Yeah, there's certain elements of that. I think we're making some changes to our underlying platform to actually make that more capable and more flexible, to actually be able to route and control a lot of how things get routed and where they get routed more effectively, so that we can because one of the things that we're kind of the way that things operate right now is you have this sort of you have something coming in on an edge. There's a policy that's applied to it, which is multiple sets of rules. Kind of the direction that we're looking into is this idea of different endpoints being able to route to other endpoints and apply policies additively and kind of route to in more complex ways. And that would support more of that sort of blue-green rolling type deployment more effectively, I think. Right now, we do have the capability. We have this kind of concept of backends in our edges, which basically are a way of splitting traffic in different ways. There's the concept of a failover backend, which is that if you can't hit one place, what's sort of the failback option? And we do have sort of traffic splitting as well. So if, let's say, you have multiple different agents are connected to the same edge, and one of them goes down, well, we'll continue to route to the other places. We just won't route to the one that's down.
Right. Good.
And I think the other part of that question looks like, is it free? I mean, the way kind of our pricing model works is we don't charge for, we basically charge on actual consumption. So how much data are you sending through? And so there's not like a extra cost to be able to do that, just how much ever data you're routing.
But we do have a free tier, right? And so you do have the ability to have, let's say, one static domain, like how you had salil.ngrok.app or whatever it was. You have the ability to come and get one static domain for free. And if you want more, then you can pay by the domain. If you want to use some of the enterprise features like the OAuth authentication that Salil showed, or some of those, again, that's kind of an extra add-on fee that you would use for enterprise type functionality. So yeah, that's all there on a consumption-based pricing model. All right. I think that wraps up all of our questions. Cody, if you want to take us out. Thanks, everybody.
Thank you, Chad, Salil. Thank you guys so much for joining us today. It's been such a pleasure hearing from you over the last hour.
There was one question that came in here, I guess. Can we use Ngrok on EKS, AKS? Absolutely, yes. You can install our Helm repos into the managed Kubernetes clusters on all three major cloud providers.
The other thing I'll also throw out is we support all of this built into Kubernetes, but we also have a number of language-specific SDKs in Go, Rust, JavaScript, and Python. And in those cases, you can embed that directly into your application. You can, and if that's a route that makes more sense for what your needs. But yeah, we support all those different platforms.
And we did do a previous webinar on deploying it inside of Amazon's EKS cluster. So if you look that up on YouTube, you'll be able to find it. Should be pretty straightforward.
Very nice, very nice. So before we close things out, and I am prepared in case we happen to get another question before we do close things out, I just want to remind our audience that we have been recording our session today, and we will be sending you an email with a link to access this recording on demand. You can also find it living on the DevOps website at devops.com/webinars. I'd like to thank everyone for their questions, their chats, and I'd also like to point you in the direction of our post-webinar survey. It's in the bottom of the chat section as well as in the handouts. If you would fill that out for us, we would just love to hear your feedback about our program today. I'd like to thank Ngrok for sponsoring our webinar today. And before we close things out, last call for questions. Are we all good to go, guys?
I think so, yeah.
All right. Well, Salil and Chad, it has been a pleasure. Thank you so much for joining us today. We've really enjoyed having you on here with us at Techstrong Learning.
Thank you, Cody.
Thanks for having us.
Of course. Well, and to our audience, thank you so much for being here with us. We appreciate you, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, everyone, and you may now disconnect.